Hi, this is Michael Becker, and in this Tinderbox lesson, we're going to talk about a critically fundamental concept in Tinderbox that you need to understand, and that's inheritance. So let's just jump right in and let me show you. So, got a Tinderbox file open, and before we get started, I just want to give the obligatory nod to Mark Anderson for his years worth of work in maintaining the ATB ref file for us and the documentation that helps us understand and learn Tinderbox. Now, what's inheritance? Inheritance is the process of a child obtaining information from the parent, and then information from that child will be passed on to its children, and so on along the ancestral chain. In the context of Tinderbox, what that parent-child relationship relates to are the value of attributes. So for example, if we think about this, if we're inheriting within attribute values from Tinderbox, if you look at the ancestral chain of inheritance in Tinderbox, it first starts with the operating system, then goes to the Tinderbox file itself, then the config files, document files, attribute files, prototypes, and then the individual notes themselves. That's the ancestral chain of inheritance. So for example, a note is a child, can be considered a child of its prototype if it's inheriting values from that prototype, i.e. has been assigned to that prototype. Notes are also assigned from their documents, from the document settings, and so on, up and down the chain. So let's give an example from an operating system. Every note, for instance, the date values of a note or attributes of a note are going to pick up the date format from the operating system. They're inheriting that date format. So if I'm in Europe, I'm going to have European date formatting when I'm looking at dates in Tinderbox. If I'm in the US, if my computer is set to a US configuration, I'm going to have the US date formatting associated with that note. Now, again, as I kind of was referring to earlier, one of the most important places that inheritance plays out in Tinderbox is with the prototype. So, as you know, you can assign prototypes to notes. And why do we do that? Well, we do that for a whole lot of reasons, primarily for this concept of inheritance. So when I assign a prototype to a note, those notes will get imbue and take on the attribute values of that prototype until we choose to sever them and make those notes independent and unique in one way or another, and which we'll explain about that in just a minute. But let me go ahead and give you a quick example of that. So let's say I'm going to pop over here and I'm going to look at this prototype folder. And you'll see I've got a prototype folder, and it has a couple displayed attributes shown here. And you'll see that these displayed attributes are shown there. Now, if I want to go ahead and change and demonstrate inheritance, let me show you how to do that. So let's look at the onAdd function within this prototype folder. And I'm now going to say color equals green. Right. So I'm going to add the value of color equals green to the onAdd attribute of P folder prototype. And now if I go look at the notes that have inherited that value, so if I look at P folder, you'll now see that child container 2 has inherited the value that we changed in the prototype, as is this one. So now if I, for example, hit Shift Option Return and add a child to this note, we'll call it note 8, you'll see that because I have now the onAdd function color equals green, when I've added that child to this note, that child took on the color green. So that's a great example of demonstrating inheritance. We can change the values of notes, and any note that's linked to that will inherit that value. Critically important. So that's what we mean by inheritance, and what we mean by that ability for up and down the ancestral chain of a note, for a note to be taking on the values of a particular parent. Let me go ahead and show you another example of that as well. Let's say in this file I create a user attribute called type, for instance. So let's make that a set, and we're going to say type is folder. Okay, so now what I've done is I have added a new value to prototype, type equals folder. And now if I go look at those notes, you'll see type equals folder has now been inherited by all of the prototypes that have excuse me, all of the notes that are assigned to prototype P folder, they have now also taken on that new attribute as within its displayed attributes, as well as the value of that attribute. Again, that is a great example of taking on inheritance. So now let's take a look at the next step of inheritance. How do we break free, right? You know, at each step along the ancestral chain, except for what are called intrinsic attributes, which you can learn about in ATB Ref, a child can gain independence, meaning that it can break free from the parent and take on a unique value of its own for a particular note. So for example, let's say we may want to dictate that, you know, a note has a different set of displayed attributes or a different set of colors. So for instance, if I want to go in here and I actually want to say, you know, for this note, I want my string to be displayed. Okay. So in other words, what we've just now done is we've broken the inheritance of from the prototype file. So you'll see that child container 1 now has my string in the display, and child container 2 does not, because we've severed the relationship of displayed attributes in relation between the this particular note and the parent note. We can also, let's sever another one while we're at it. Let's go ahead and change the color of the shape. Actually, no, let me do this one. I'm going to go ahead and I'm going to open up the inspector, and I'm going to change, because I'm an outline view, so changing the shape won't be visually appealing. I'm going to go ahead and change the color. I'm going to make the color of this note bright green. And so you'll see now we've also changed the color of this note. So that's a way of demonstrating to you how a note can take on an independent set of values for certain attributes from its parent, from the prototype that's been assigned to it. Now this is really important too when you think about what it means when we're for example running edict code or rules or actions, because edict code, rules, and actions too are inherited values. So if I were to edit this, and you'll see right here, I know that this edict is being inherited from the prototype because it's being it's showing that it inherited. Now if I make any changes to this local local edict, this note will then be, the inheritance of that edict will be broken from the parent and then independently running in itself. And that's a whole other training when we get into action code in relation to inheritance that I'll do. So I'll come back to that later. So that gives you an example of what it means for a note to be independent of itself, and to be able to manage that. And as we've shown, this note is still adopted the folder badge from the parent prototype. All we've done is change two attributes: its color and its displayed attribute view, but the rest of the elements tied to that note have maintained inheritance. So that's a critical concept to keep in mind as well. Now, the next thing I want to show you when it comes to inheritance is this: what if we want to reestablish or reenable inheritance back to a note, which is something you'll often want to do, especially when you've broken the edict rule relationship between a prototype or note. And again, I'll give you an example of that in just a minute. So there are 4 ways to be able to reestablish inheritance. You can use the quick stamp in the document inspector. You can get info, use the get info view. You can use action code to do that. And you can use the main menu, use the menu normal options you'll find throughout the Tinderbox in the contextual menus. So let me give you some demonstrations of each one of those. So you'll see here, and I kind of you saw how I broke the color by going here and changing the color of this note. So if you'll notice here, if you recall, I broke the inheritance by changing the color green. When I did that. So now if I want to go back and leverage a quick stamp, I can find the color, and you'll see that right here it says assigned to this note. So what this is telling me is that the bright color green that is currently assigned to this note is actually, this note is now independent. It's not related to its prototype parent. Now if I go ahead and uncheck that, or I hit this little button right here, watch what happens. It defaults to the default value of Tinderbox, which is the color 7, and you'll now note that it is taken on that new color. Now watch what happens. Let's go back to the point of ancestral change. Let's look at the prototype value 2. You'll notice that the prototype value 2 is the default of the system. So in that regard, if we go back to our ancestral our ancestral view, again, even the prototype is taking on the system defaults. And so that's why it went to default. Now let me show you a different way of considering that. So let's say I want to go here, and I'm now going to make the parent here cyan color. So we're now going to say, actually I'm going to make it more pronounced. Let's say poppy, right? So every folder is going to be the poppy color. So you'll see the second I did that, the notes that were related to that folder changed because they took on the inheritance. They inherited the values from their prototype. And so now, and you'll see here, you'll see now this one went from saying default, which we just saw before, to assigned to this note. So the prototype has now taken on its own independence from the system of Tinderbox to be its own color, in this case, which is poppy. And you'll see that those notes have as well. And you'll also see that they've said inherited from this prototype. So now if I go ahead and, as we were showing earlier, I'm going to make that back to bright green. And you'll see now if I go back here, you'll see this one has the color green assigned to it, assigned to this note, whereas this one is inheriting from the prototype. So if we now want to enable this note to be able to basically re-inherit from the prototype, I can just click this button right here, which does that, and you'll see it immediately changed back to poppy, and its status has been, its inheritance has been reconnected back to the prototype. So that is one way, using the quick stamp method, to be able to quickly inherit and reconnect the inheritance to the note. And let me show you, let's fix one other one here too. You see how the displayed attributes of this note are different. Again, I could do that same method. I could go ahead here and type displayed attributes, and you'll see that the displayed attributes are for this particular note are assigned to this note. If I click this button, you'll see they quickly my string quickly goes away, and the displayed attributes for this note are connected back to that original parent. Now let me show you a different way to go about doing that. So if I'm going to add the my string back again, whoops, I'm going to add the my string back again. Okay. And we're done. You'll quickly see that the inheritance of displayed attributes, if I go ahead and close this out and open it up again, you'll see that to refresh, you'll see that this note's displayed attributes are again assigned to the note. We broke inheritance. So that gives you an example of what's happening. And then if we go back to the ways of re-enabling inheritance, remember there are 4 ways to do that. You can use the quick stamp. That's what we were just showing you. You can then also use what we talked about, the contextual menus. And there's various examples of that. So for instance, a contextual menu would be if I go to the note here, and you'll see if I look at badge and I scroll all the way up where it says normal here, this is essentially the default of a Tinderbox note. So if I select normal, and I'll just go ahead and do that, you'll see that the note would take on, whoops, I did the wrong thing. You'll see that the note would take on different activities. I'll go ahead and put that back. The other example of a contextual note change preference is if I go here and I hit reset. This is an example of me hitting reset, and this reset button is another way of resetting the displayed attributes for a particular note. I do this all the time. That's why I'm pointing it out. So that way you'll see I've just reset the displayed attributes, essentially reconnecting the inheritance of that particular note. So that's another way of going about reconnecting the inheritance. So we've shown you 2 so far. We've shown you using quick stamp and the contextual menu elements for reconnecting Tinderbox inheritance. Now let's go back and look at the other two options of re-enabling inheritance. You can use the getInfo function and you can use the action code function. So let's look at getInfo. So I'm going to go ahead and for this particular note, we're going to re-break the inheritance. So this now note, as said earlier, let's go look at color again. You'll see that we have, color is now assigned to this note. We've broken it. Now, if I go here and I use the Get Info menu and I type color, okay. If I'm in the Get Info menu and I right mouse click here, I can say use inherited value. So what it's going to do is it's going to go back to inheriting the value from the prototype, and so it's going to take on the poppy color. So that's another way of reestablishing inheritance. And then the final way of reestablishing inheritance is this. So let me go ahead and show you, as I was referring to before. Let's say I go ahead and I break the inheritance for this edict. So rather than using parentheses, I'm going to use brackets. So, and let's go ahead now and run this up. So you'll see this note's edict is showing a brackets, whereas this note is showing parentheses, as is the parent. So essentially what I've done, and you'll notice the word inheritance disappeared. And if we go look at the quick stamp again, you'll notice here that it's assigned to the note. So remember, there's a lot of ways that we can re-inherit the value of this edict. I can use the quick stamp like I was just showing you. I could go to my get info and I could type in edict, and I could use the update use inheritance method to reconnect the quick stamp, but that's only for individual notes. Now, if you like in many of my files, some of my files have 8,000, 9,000 notes, especially, and so if I'm wanting to reconnect the edict or rule that's running for those notes, doing that one by one, incredibly painful, if not frankly impossible. So what you would want to do is run an agent. So you'll see here, this is the next way of running of establishing inheritance. What I can do is say, run an agent that essentially says, go get all of the notes, and I'm going to remove this code right here just to show you. Go get all of the notes that are descended from the parent container, which happens to be this one, and its prototype, and that have the prototype folder. So, and I'm going to turn this prototype or this agent back on. And it's going to go and it found it very quickly. Here are the two notes that are related to, or that are descended from parent container. So that I ran my agent and the query went out and found those notes. Now what I want to do is I want to paste the agent action back in, and I want to tell Tinderbox, for the notes that you found that meet these criteria, which is basically in this parent container and has a prototype P folder, I want you to reset their edict and rule attributes back to their default value, to essentially their inherited value. And the way you do that in Tinderbox is you basically say, edict equals, and then you use the semicolon to stop the argument. And see our demystifying action code training to learn more about the syntax of agent actions and action code. So you'll see here that I'm saying edict equals semicolon. So edict equals its default value, hard stop. And then what I'm saying, rule equals its default value, aka its inherited value, hard stop. And so when I do that and I hit enter, so I'm now going to rerun the agent. Okay, and so what's going to happen is, and sometimes if you want to reforce the, it worked. Okay, so you see this automatically changed back from brackets to parentheses, and if I go back here, you'll see that this note's edict has been reset to the inherited value from the prototype. So that is another great way to reestablish inheritance, but do so in a programmatic way through the use of an agent. And then what I'll tend to do is I'll just then turn that, do a -1, by putting -1 in an agent priorities. That essentially turns off the agent, and you can then later come back to that at some future time if you want to be able to reestablish edicts or rules in mass across your file. Now you might have seen this turn, this went to off and its name changed and all of that. Well, the reason why that's happening is I have a rule here that resets agent names when the note has been turned on or off. So that's something you can take a look at or play with later. But so long story short, and let's go back here to re-enabling the stead of the training. So essentially what we've just demonstrated is the 4 methods of re-enabling or re-establishing inheritance in your Tinderbox file whenever you need to or want to. And you can learn more about that in the ATB ref. And speaking of the ATB ref, again, I just want to give a nod to Mark, and the author and maintainer of the ATB ref. He's done an amazing job and has really helped out the Tinderbox family immensely with this work. So that is inheritance, and it's a fundamental concept that you really need to know and understand to get the most out of Tinderbox, especially as your files get larger and larger and larger, and especially as you start adopting this kind of metacognition thinking, where you actually are using more and more attributes as you build out and leverage your notes for your knowledge management and sense-making efforts. So thank you very much. I hope you enjoyed that session, and if you have any questions, let me know. And as always, if you wouldn't mind, please like this video, as well as be sure to subscribe to the channel. Thanks again. Bye.